Hey guys, we have ourselves a div 3 today, and I don't remember what this code is. Oh yeah, that. We have ourselves a div 3, and I'm just gonna jump into it. For some reason I do better on these, so I'm gonna try like going harder. Yeah, okay. So this is fine. One is less than equal to 10,000 plus. I mod 3 is not equal to 0. Alright, let's not do that. And then basically we're just implementing it because the constraints are small. What? Oh, have the digit 3. Okay. X greater than 0. If x mod 10 is equal to 3, pos is equal to 0. What? Okay, why am I doing this? I just need to read the problem. What now? Why is there 3 here? Oh, wait. How did I get to not equal to 0 there? No, wait. This should be not equal to 3. And this should be and. Genuinely, what am I doing? Okay. So the number of people have stood in a circle. This number is even, no doubt. Okay, so I figure out the number. So half of n is a minus b, or like the absolute difference. Now what is negative 1? Oh, right, okay. If a times d is greater than 2 times d, yeah, it's kind of an annoying case. Oh, wait. Oh, yeah, I'm trying to read into arrays. That doesn't make sense. No, it's 0. Okay, I have to do +1, otherwise mod doesn't really work. Yeah, I think that should be fine. Infinity table. Okay, so like that. Right, so it's basically number spiral. Yeah, this is literally a problem on CSES. That's awesome. Maybe it's like reversed? Oh yeah, it's even easier. Okay. So Cn2k for I is equal to 1, I is less than or equal to just some big number. If I times I is greater than or equal to k, and this is the first number that we look at. Okay, now we have k things. So if I is less than or equal to k, then print, so the column would be, so like we're asking if it's on this column or if it's on this row. So the column would be k. Now the row, what? Okay, so the row is I. Yeah, else the column is k, and the row is like I minus equals k minus 1. Right, it's I minus equals k, and then it's like k minus I. The way I'm getting these numbers is just doing like, you can do small examples in your head. This could actually be wrong too, I'm not entirely sure. A little bit, yeah. So 11. Oh wait, I got this all wrong. Okay, I got this totally wrong. K is the number. Yeah, I don't know what I'm doing. K-I-I. Sorry if that was confusing. I got everything wrong there. 2, 4, 4, 3, 1, 3, 2, 1, 1, 1, 1, 2. Looks good. There are 2 cases there, but I think I got it right because of the second test in the sample. Okay. Erase any digit of the number. Now you're given the integer n. Add 1 digit to the right. Make it a power of 2. Okay, I'm guessing try the power of 2. Try the powers of 2 and greedy. Makes sense. I'm gonna try the power of 2's up until 62. Makes sense. I think that's the right function. Okay. If What am I doing? S dot. No, if C is equal to TP, two times P is the number of characters saved. We're like basically doing greedy on the numbers. We're like taking like a subsequence, and then the rest we have to stick on. And so 2 times P is the number of characters we saved. 2313002134492. That's a large sample. So I think it's fine to do that. It's a very large sample. Okay. String S. Those are just breezing through this, I guess. Let's see. Is F1 easier by any chance? Sometimes that happens. Okay. Following actions until the string S is empty. And to the right of the string T, the string S. T is T plus S. Okay, that looks annoying. Let's look at this. Now, given an integer n, k is 10. Okay, we can generate all the numbers, I guess. We can just brute force this. Okay, so one D is less than 9 D plus plus. R is equal to 0. At 1 dot insert R. So 0. Yeah. Let's do this. Yeah. So for each number, I'm gonna find a better solution to this, but No, wait, it should be. Is that bit on? If so, D, otherwise E. R is equal to 10 times R plus B. 2.insert R. Now, cn.n. One is less than okay. There should be something. What's this for 2? 1, 9, 9, 8, 2, 4, 4, 3, 5, 3, 2. Makes sense. Equals 0 is less than 2 to the k, plus plus. Actually, let's do better. Yeah, otherwise it's like probably gonna TLE, and I don't want that. It makes sense. Okay. We're good. Okay, people are doing E, so let's do that. So let's look at the last character. Actually, first we can find out the length of S. Or no, we can find out the number of characters in S. And it will tell us the number of the number of characters in T. That would be the number of times the operation was done. Then for the first character, we can find the number of this character in S, because it will show up like s.length times, or the number of amount of the last character times like the length of the string. Yeah, okay, this actually shouldn't be that bad, so that's fine. I'm gonna do that then. Cn to T. Okay, we're gonna do frequency. F C minus A. And in fact, what we can do is we can find out the order right now. For L equals T dot length minus 1 and minus minus. if s dot find ti is not equal to s dot end, s dot insert ti, or dot push back I. That didn't work. What happened? Why? Yeah, equals. Ti. Yeah. So BAC, LCO. Yeah, okay. Good. So let's continue now. Now we do this again. For car C ord, bool pos equal to 1. Okay. If f c minus a, I think this is easier. Is no, whatever. If f c minus a res equal to s dot mod, what do you r is not equal to 0, pos equal to 0, break. Otherwise, count plus equals fc minus a mod r. That should work. Nope, does not work. Now we subtract 1 from r, because now we're going back. Carp. Nice. What? Oh, divided by. Otherwise, I'm not actually sure what that does, but I don't think it's right. Still not right. Now I'm very confused. Okay, I don't know what that substring did, but whatever. So what's with the last one? Oh god, okay. Well, this is fine actually. We just need to do a bit more verification. Yeah. We just need to make sure that, so string s is equal to this. S. Now, for li equals 0, I is less than s dot size, I plus plus. Okay, so if let's see, p plus count is greater than t dot length, pause equal to 0, break. If we don't have enough characters, we're automatically done. If t dot subster p count is not equal to 2v, or to cur, pause equals 0, break. Otherwise, p plus equals count, car c cur, if c is not equal to ord. Now we reverse the order. I temp dot pushback c cur equals temp. Awesome. Why? Yeah, count minus equals f ord say over I plus 1. Do need to modify count. That's a good thing to note. Okay. So 1. Yeah. A B A B B A B. 1. A B C B A A. BAC. Yeah. Let's define TI is equal to S.end. Insert. Pushback. For car C ord. This can be more efficient, but I don't think it matters. For each character in the ordering, if the frequency is not 0, then do that. Yeah. The frequency is divisible by R. Sorry. Divisible by R, then yeah. So if not pause, do that. Just to prevent some runtime errors. Right. I'm just trying to make sure it's all good. I think it is. Hope so. Nice. All right. So what's with this? Now we can't explicitly generate the numbers because there are too many of them, but I believe the frequency is like, okay, I have an idea. Let's check something. Let's okay, yeah, 1.1 billion. C plus C equals not F V mod 10. F V mod 10 is equal to 1. C if C is less than or equal to 3, minus less equal to 1. Alright, so what is not if that? Yeah. I'm trying to see if they're frequent enough is basically it. Okay. Okay, this should be fine. What number did I give as input? Oh yeah. So 1. And the number of tests is 10 to the 4th. Actually, that's kind of hard. Okay, wait. 3 to the 10th. There's not that many. So there aren't that many numbers. The problem is just generating them. Okay, let's copy my code for F1 and add some code for... Actually, how does this work? Okay, beautiful integer. Okay, so if k is big enough, we can brute force, I'm guessing. Yeah, because this amount is fine. The problem is k equals 4 is I think the hardest. I'm not sure. What exactly can we do? Suppose we iterate over the digits used, then if we're going through the digits we're using, then Okay, let's just do that. Wait, can we even do that? This is slightly annoying. At least the way I'm thinking about it. I feel like I'm missing something. Okay, is... Wait, this should be fine. So Tree 66667. Isn't that the worst? I don't really understand what I need to do here. So if I do this, wait. It's got to silence something. I'm just gonna write this thing. If the yeah, at 3 dot push back b dfs v times 10 b c. Okay. Come on. What's the problem? Alright. Why did I do this? Why did I do this? I'm just making myself suffer here. Why? That equals 1 digit. That equals 10 digits. Oh my god. What is this number equal to? What? Oh, come on. Okay. Okay. Alright, well that was a mess. Okay. It's not the best. In fact, I believe there's a decent chance it may be hacked. I don't know, I must have overcomplicated this somehow. I don't know what happened here. Like... Okay. If I minus last is greater than worst, worst equal to I minus last. like the worst of it is in pre-computation. But we'll see anyways. Hopefully there's no dumb Codeforces bug again that happened. Because last time they just like screwed over people that did pre-computation. And it was very dumb. Okay. I guess DigiTV is just like a way to do it. I don't really know. I'm like, yeah. It's also kind of suspiciously close to the time limit. How are people doing on this? People are getting accepted with very high runtimes. Some people are getting accepted with not very high runtimes. Which is also a thing. Whatever. I guess we'll see if we get hacked. That could happen. I'm trying to CV is equal to, what is the number specifically? Last plus 1. If last plus 1 is less than one. Interesting. That is an interesting number. Okay. Here's like the worst you can do, or a number similar to that. So I'm going to see if I can hack myself here. So if I can, that would not be good. N equal to k is equal to 4. Oh, that's great. Okay, dude, these guys and their tests. you serious? Yeah, it really is 10 seconds, huh? Well, I'm screwed. Make it 5, it should be a lot easier. Make it 3, it should be a lot easier. The problem is 4. Alright, why did I submit this? Why did I do this to myself? Should not have submitted that. But I don't... Oh, God, man. Not smart enough right now to think of a better solution. Is digit DP supposed to be the way to go? I mean, it's like, it's 1 second. I guess DP is fast. I have no clue. But that's not right. So that's stupid. I'm just gonna code digit DP. I would guess. I don't know. And there's some greedy way to do it too. Don't really care. For bit is on, we're gonna use that digit. done? See the random variable number, variable names. Sorry, because it's going to be unreadable. I'm mentally done right now. And it turns out I'm not done because this is not correct. It's very easily hackable. So if we, so if j is greater than k and b not of variable names, not of letters, MVP is equal to min MVP dig times k plus VP. I guess that's how that works. And v of 2, something like that. MV of p should be MV of 0. What am I starting off with? It's gotta be less. What is it? While r is greater than 0. I guess. I have no clue. Oh, I want this contest to be over. I really just want it to be over. Like, seriously, I want to be done with this problem. Okay, let's be done with this problem. Come on. Okay, doesn't matter. Assuming this won't work. Assuming I'm missing something. It's just returning a number. What the hell? That makes sense. Yeah, I don't even know what I'm doing here. It's not even like doing anything. Well, okay. Let's see how this does. Can it TLE? Might TLE. I guess it does. Awesome. Well, let's stop making tiny vectors, because that's gonna suck. Wait, what? How does it even work? I don't understand how this works now. Okay. I'm gonna need +1 here. Please let me go. I need this. This should be a bit somewhat faster. Test 3. You serious? I really don't get this problem. There's gotta be some super simple thing that I'm missing. Or something like that. I mean, it's not super simple, but it's like people are getting it. How slow is it exactly? That's pretty slow. Alright. Maybe it's just some greedy. We have 1 digit. Just contemplating what I've done with this problem. I'll enjoy this 7th for a little bit longer, but it's not like my F2 is going to be hacked. It's just wrong. So that's awesome. He's having trouble with it too. This is going to be hacked. So maybe going for F1 wasn't the move. It's probably better to do E. And then do F2. I guess I'll do the greedy. There's nothing else is able to pass. I don't know. Guess I should have looked into that more. So the first thing you can think about is using like the what is it? First thing you can think about is like using the first k distinct digits and then see if you can fit the rest of the number to that. Because you want like as large of a prefix of the number to be the same as possible, maybe. I have an idea. So for I is equal to 0, I is less than, no. Take that pushback V mod 10. Break. Now V plus equals 2 to the Y. Get So it's possible that it doesn't work, in which case we can take the last digit we used and increment it by 1, and then that will work. Pretty sure. I don't know why I did that. I used eval as the set's name. That doesn't work at all. Why does that not work? 177. How exactly? How the hell does 3 even like get there? Where is 3 here? It's no, where could 3 be? How could 3 be anywhere in this number? How is 3 anywhere here? What am I doing? Is it eval? Paste it in there. Yeah, okay. Don't understand how 3 could be anywhere here. How is it 3? Access a bit mask. What if we don't do this? Oh. Right. Okay, yeah, that makes sense actually. Otherwise it's just total garbage. Alright, so this, you don't need the DP for this, I'm pretty sure. I could just work with like greedy. What the hell? Okay, this problem is just killing me. This is genuinely just... Why can't I be done with this problem? I just can't be done with this problem. Holy Christ. Where would this be wrong? When it's handling like zeros? Is it somehow doing the K thing wrong? Like, I don't know how. I'm making sure the digits like work like that. It only uses at most the first K characters. Oh. I guess that's an important thing to... let's see. Well, actually, wait. No, it doesn't make sense. It only gets to K if we run out of characters. So this shouldn't actually change anything. So if we run out of characters on the prefix, then what can we do? That's what we do. That's what we do. It's so scuffed at this point. That should work. VDI is less than 9. Yeah, that should handle a very specific case, I guess. I'm gonna try that now. You're killing me. You're actually killing me. I need to solve this problem to be done, but I'm not gonna be done. Ever, apparently. Do I even upload this? What the hell? Like, genuinely? Why? Just why? Oh yeah, the case works worse than I thought, huh? When we finish a number, we want to put all ones at the beginning. Okay, new plan. And it's even worse than the original. Genuinely don't know how I'm going to explain this either. If not this. X vd dot push back X. we're going to consider 0. Genuinely not caring about penalty anymore. Seriously, like I can get any rank I want. I want this problem to be gone. I want to be done with this. That's all I want. Can't this problem just be gone? I'm trying each prefix of digits. If we have an extra digit, maybe we put on a 0 or something. Now it's around 10 to the 4th, I guess, runtime. Should be fine. No, it's not fine. It's not fine. Why would it be fine? It's never fine. I'm going insane. Like, seriously. Don't know what's up with this problem, but I'm dying so hard on it. And the tests are garbage, but they're also somehow not. Well, the problem is garbage. That's what matters. At least the mic's still working. I think. Let's mess with the table. I'm talking too quietly for it to be heard. I could, like, this is easy to brute force, but I don't really want to. Actually figure out what's wrong logically. Ah, that would do it. Let's try that now. Seems like anything can pass the sample. Okay. Well, that's over. That was awful. So yeah, my real penalty is actually going to be like down here, just because that problem hurts so much. Yeah, it's gonna be like this pretty much. What would it be? 1903, so 43 more minutes. So 88. So 43 plus 6 penalties. So 223. I guess that puts me like around here. Well, this was fun while it lasted. Oh, this should be a correct solution. I'm hoping. Yeah, same runtime. Okay. Alright, I'm not even gonna comment on anything. Let's just get solutions over with. So for problem A, k is at most 1,000, which is pretty small, and the tests are most 100. And they actually given the samples, so the samples could be useful for a problem like this, that the answer for 1,000 is 1666, which is also very small. It means that the maximum possible answer is 1666, because the maximum, or the 1,000th element in this sequence is 1666. So what you can do is simply, either you can brute force, or you can generate the sequence beforehand via brute force. And you can basically just figure out the number once you generate the sequence. You just print the kth element of the sequence once you generate it. Another way is binary search. You can do it like that and it'll be efficient, but it's not necessary. So code-wise, I'm just brute forcing per test case. Go up to, because the maximum answer is at most 1666, if you iterate to any number after that, then it's fine. You check the conditions, and then when you've seen k numbers that are good, just print that one. So this is the kth good number, and then I would just print that. For B, now I use the drawing tablet. Essentially, we know some pair, and that's really all we know. We know some pair and we want some other number. Maybe this number is part of this pair, it doesn't really matter. But what we're interested in is, what is n? And the thing is, say this is A, this is B, and this is C. We know A and B are going to be opposite each other, the opposite position. So what does it mean about n? Well, consider the way this circle works. We have A and B. I'm actually going to move this out for a second. We have A and B, then we have some circle here. Pretend it's a circle. Then we have A, we have half of a circle. We have B, we have another half of a circle. And then we go back to A. Pretend this is the same size as this, even though it's obviously not. And then, actually I could just steal this diagram, but the point is that A and B go down the middle. It's like a diameter of the circle, which means that there are two halves on either side. So A and B are opposites. And what does this mean? It means that whatever n is, there are n over 2 seats, or n over 2 people, when you traverse this semicircle. And there are also n over 2 people when you traverse this semicircle. So A and B are n over 2 apart. So now assume A is less than B. If not, swap them, in the code. So without loss of generality, I guess. Without loss of generality, assume A is less than B. Then what does it mean about n? Well, we know A and B are n over 2 apart. So B minus A is equal to n over 2. To find n, we just solve for it. Equals n. So n is equal to 2 times B minus A. Or, the way I use in my code, actually, it's the same thing. It's just the 2 times the absolute value of B minus A. And that way, if B is less than A, then this formula will still work. It's just the absolute value. So that gives us n. So now that we know n, well, we know that C is going to be n over 2 apart from its counterpart. So essentially you can do some casework or you can do some like math involved. So essentially if c is greater than n over 2, then its counterpart is going to be smaller, because when you go around the circle, it's going to circle back to 1. So if c is greater than n over 2, then the answer is c minus n over 2. And otherwise, the answer is c plus n over 2, since c is on the smaller half, so its opposite is going to be on the larger half. So that's how you get the answer. The problem is, for some annoying reason, they decided that they can give you invalid circles. But the only real problem there is if, like, it's only invalid if, like, any of the numbers are greater than n, because obviously they can't be in the circle then. If there are only n people and someone's numbered greater than n, then that's not possible. But that's the only, like, case for invalid. So specifically, if the maximum over the 3 is greater than n, then we have some number that's greater than n, so it's invalid. Another way to think about this, if you zero index the indices, then this is sort of the same logic you go through when you're doing like modulo. And in fact, usually they teach modulo around like going around a clock. When the clock like circles back to 0, then like that's when you do like a modulo thing. Like if you add like time, if you add 7 hours to like 8 o'clock, then it's like sort of like mod 12 basically. Oh, like not exactly, but it's pretty close. And this is sort of a similar process. So you can think of it like it's essentially c plus n over 2 mod n. This is zero indexing. Because if you one index, then it's going to be messed up. Because like 2n is a possible location, but it should be, but it's going to get modded to, or n is a possible location, but it's going to be modded to like 2. Or modded to 0. So first read the input, then we take the absolute value. Now we see if it's invalid. If the maximum is greater than n, which is in this case 2 times half of n, then the answer is -1 because there's no, like, it's invalid. And otherwise, we subtract 1 to 1 index c, and then we mod it by n, and then add 1 again to make it 1 indexing. Because they couldn't label them 0 to n minus 1 because they hate us. That's the vibe I'm getting, that the setters hate us. So the maximum, yeah. By the way, you can take maximum more than 2 elements by doing this. It's kind of cool. Also, just to make sure it's clear that d is not n. D is half of n. It is the difference between a and b, which, as we've deduced, is n over 2. And because n is even, this is fine. So c is like, there's this problem called number spiral from a site called CSES, and it's like basically almost exactly the same. You're given, you have this spiral pattern. Actually, it's kind of reversed. This is more like, this gives you the coordinates and you have to print the number. This gives you the number and you have to print the coordinates, but it's like, it's the same kind of logic. So the way this works is, essentially we're going to divide it into squares. So the first square is just, I'm zoomed out. So the first square is just 1. Then the second square is going to consist of the numbers 2, 3, and 4. Then the third square is going to consist of the numbers, or like, it's all of these plus like the next few. And then so on. We can consider these like independent sections. It would be convenient if we knew which section we were in. For example, if we knew we were here. That's nice because then either it's along this vertical section, in which case the column is guaranteed to be 3 and the row is just something. Or we're on this horizontal section where the row is going to be 3 and the column is going to be whatever. Yeah, so the first thing is, how do we just want to find the square first of all. And we can do this in multiple ways. I did brute force because it doesn't matter that much. Like, runtime is fine. You can do binary search, for example. Basically, we want the first number where we want the smallest k, where k squared is greater than or equal to, no. Other way around. It's the minimum, like, the side length, like x. This is x, where x squared is greater than or equal to k, because the input is not n, the input is k, because they love that. So, if you can tell, I'm not happy with this contest. So we want the minimum x where x squared is greater than or equal to k. Yeah, so what does it mean about this? So now we know, like, we know we're going to be in this group. For example, suppose we have, like, let's take the input of 14. So k equals 14. So the minimum x where x squared is greater than or equal to k is x equals 4. And it's going to be in this, which represents it's going to be in this group. It's going to be like 4 away from the origin, sort of. If you think of it like moving a king on a chessboard, it's going to be 4 away from the point 0, I guess, if you think of 0 like this. I don't know. I'm just trying to like represent it in a way that maybe makes sense. So, what do we do with this now? The next part is finding out whether we're on this vertical segment or we're on the horizontal segment. So the first thing we can do is notice that this is exactly x numbers, which means that if we're among the first x numbers of our current like section, then we know we're going to be in this group. So I maintain my 1 indexing. And so what I actually do first is, once I get x, then I subtract out, this is like assignment, I subtract out x minus 1 squared. And all this does is it renumbers the numbers that we're considering. So instead of starting from 10, we're starting from 1 here. So it sort of just like shifts the way we're thinking about it. And this is nice now, because if k is less than or equal to x directly, then that just gives us the formula. Then the answer is, well, what's the row? The row is k, just k. Because like, if we're on number 3, the row is 3, and so on. And the column is x, because that's what we determined. Now, otherwise, we know we're in this segment. So once again, I'm going to subtract x from k, and all that's going to do is, similarly to the previous thing, it's just going to renumber this. Actually, I might subtract that minus 1. No, this is right. Yeah, and so now we know that the row is going to be x, but what about the column? Well, this corresponds to column 1, this corresponds to column 2, and this corresponds to column 3. So if we notice, the sum of these two numbers is equal to k, or equal to x. Like 3 plus 1 is 4, 2 plus 2 is 4, 1 plus 3 is 4. So just working out some small examples, we can deduce that the answer for this, the formula for the answer, should be x minus k. And that's basically it. So if you're worried about indexing, which is reasonable, like I am too, it helps to just work out small examples and then find the pattern from there. And then you can check your formula on the small examples and make sure that it's right. So in this case, here I'm reading in k. I'm using I for x, but it's the same thing. Like, just replace every instance of x in this explanation with I for my code. You can iterate up to some large number. 10 to the 5th squared is 10 to the 10th, which is larger than any number we could possibly get. So we just need to iterate to some number that's big enough. In general, it works in O of square root of k, just because like we're iterating over numbers until the number squared is larger than k. So the number we'll find is around square root of k. So we can speed it up by like only searching around square root of k, but I don't care, it doesn't matter. So now that we find I, it's just doing these formulas. So subtract out I minus 1 squared. Then if this, print this. Otherwise, do another subtraction, print this. Yeah. So the trick here essentially was dividing the problem into like easier and easier subproblems that we can manage. First, instead of thinking about it like the whole pattern, we're simply finding the largest row or the largest column that we're at. Or we're finding like the larger of the row in the column. We're thinking about it like sections, and then we're going to find this section. And now we're finding the number within this section. And even then, there are two subparts to the section which we can solve like separately. And then eventually we just reduced it to a straight line in both cases, which is easy to work with. So yeah. For this problem D, it is sort of another brute forcey problem. The idea is there are not that many powers of 2. 2 to the 62 is 4 times 10 to the 18th, which is like big. And it's big enough that we like, there's not much better we can do. Because think about like the most basic set of operations. Suppose n is equal to 10 to the 9th. Then like it's 1 0 0 0 0 0 0 0 0 0. So what we can do is in 9 operations we can remove all this and then be done. And then we'll have 1, which is a power of 2. Suppose n is less than 10 to the 9th. Then we have less than or equal to 9 digits. Suppose they're so that like none of them are powers of 2. Then we can remove all the digits and then add like a 2 back in. And this would be done in 10 operations. We're removing 9 digits, we add a 2 onto the end, and then now we have 10. Wait. We actually have to go to 6 to the 63, but the thing is, in this case, we'll have to have a 2 anyway, so it doesn't matter. Yeah, essentially, so as long as so if we try like some massive power of 2, for example, like 2 to the like 100th. How big is 2 to the 100th? Google says it has 30 digits, and we start off with at most 10 digits, and probably it's not valid. So we need to remove some number of digits, and we need to do at least 20 operations, which is bad, and it's pointless because we already know we have a solution that's guaranteed to work in 10 operations. So there's no need to try any number that's larger than 19 digits. And in particular, there's no need to try any number that's equal to 19 digits, because no matter what, we can do better. So the only numbers to consider are 18 digits. In fact, the best thing to do is to go up to 2 to the 63, because this is the largest power of 2 with 18 digits. But the thing is, if we have 2 to the 63 as a substring, or like if we have 2 to the 63, then we need to have a 2 as like the second digit. And so then we can do this strategy, but instead of removing all 9 digits, we simply remove 8, leave the 2, and then we do it in 8 operations, which is better than we can ever do with this because we can only have 9 digits. So the point is, like, there aren't that many powers of 2 we're considering. I iterated up to 2 to the 62, which is like 4 point something times 10 to the 18th, sorry. And that's fine. Or it got accepted, at least. So yeah, so now that we're fixing the power of 2 that we're trying to make, how do we actually like evaluate it? How do we know how many operations it takes? So we have some original number. And all we can do is we can cross out some digits and we can get rid of them, or we can stick on some numbers to the right. So let's consider like the digits we keep from the original string. because we can only add digits to the right, the digits we keep from the original string must be the first digits in the power of 2. So we're really asking, like, how many of the first digits in the power of 2 match up with numbers in the original string. For example, let's say we have, like, the power of 2, 262,144. Pretty sure that is 2 to the 17th. 2 to the 17th. 2 to the 18th. That's because the USCO problem. That has that name. So this is the power of 2. So 2 to the 18th is equal to this. Let's say with the original string of like 253612. So now 2 matches with 2, so we can keep the 2. 6 does not match with 5, so there's nothing we can do with the 5. We have to get rid of it. 6 does not match with 3, we get rid of the 3. 6 does match with 6, so we can match those digits together and then not get rid of the 6. 2 doesn't match with 1, so we get rid of it. 2 does match with 2. So now we're left with 262, and then the rest of the characters we just have to stick on to the end. So that's the basic idea. We're going to like go through the subsequences, and whenever we find a match for our current position in the power of 2 and the string, then that's like the answer. Or that's a digit we can keep. And so then the cost of doing this is simply the number of digits we remove plus the number of digits we have to add on. So suppose this collective string is like t, and then the initial string is, I guess, n? Is that what they... Oh, they call it a number, but it's basically a string. So then the answer is the length of n. This is notation like that means length, plus the length of t minus 2 times the number of characters we kept. And the reason is because if we don't keep any characters, then we remove everything from n, which means we use all of those like operations. And then we add everything to t, add everything from t, which means we have that many operations. But when we keep a character, it means we don't remove it, so we lose one in this field, and we don't have to add it, so we lose one here, and so we ultimately like save 2. So that's why we subtract 2. So the strategy is try all powers of 2, find out this expression, find out the number of characters we keep, and then take the minimum of all the costs. So doing this, I'm just doing exactly this. There's a function called toString, which is nice because then I can treat everything as a string. And then for each character, like greedily match it, and then take the minimum of the expression. Okay, right. This problem is sort of like, it's a bit like, I guess like a puzzle where you have to like, you're given some information that's stored in a weird way, and you have to sort of decode the initial string. So think about like the way the process is going to work. In particular, consider like the initial string like abacaba. So the way this works is like initially we do this, and then get rid of b. So then we're left with AA, CAA. So these are the remaining characters we have. I guess we get rid of A, yeah. Then minus A, and then C. So we know at the end, like the very end of the string, the only remaining the last character of the string, like maybe we had 2 C's, so we have 2 green C's at the end. But in this case, we don't. But like the last character of the string is going to tell us the last character that was removed. Yeah. So we know the number of like rounds that were done. The number of initial character, or the number of like distinct characters in S is just the number of like distinct characters in T. Because every character in S is going to show up in the first part of T, and there are no other characters. So initially, we can automatically find out the number of distinct characters in S. Call this like X or something. Is the number of distinct characters in S, which is equal to the number of distinct characters in T. Because again, every character in S will show up in T, and there can't be any more because otherwise it would be in T. So now we know X. So how many times is C going to show up? Let like, let's see, for more notation, let like f of C be like the frequency of C in S specifically, not T, S. Then we know that C is going to show up in T, or in particular, the last character in the order is going to show up in T. Use some like other color, like gray for this. Doesn't really matter. C is going to show up in T, FC times X times. Because we have exactly this many characters of C each time. Like each round we're going to have the same number of C's. And we have X rounds, which means that like that's just the number of times it shows up. So we know that the frequency of C in S times X, the number of rounds, is the frequency of C in T. So we can solve for the frequency of C in S by simply dividing. So FC is equal to this, the number of C in T, divided by X. And that gives us that. So how do we find out the next like distinct character, the next one that was removed? Well, as it turns out, if we go backwards, it's just going to be the first character that isn't C. Because like we know that the next part of the string is going to be the previous round, which is only going to have 2 characters. It's going to have the character that was removed before C, and it's going to have C. And like going in a similar fashion, if we go backwards through the string again to whatever was in the first round, or the previous round, we're going to find the next character that was removed. And then we go forward, and then we keep going, and then we find the next character that was removed, and the next character. What the hell happened? I just can't erase this. Okay, yes. So we go backwards to the string. Yeah. So the strategy for finding the order, because of the way this works, is we can simply go backwards through the string, and every time we find a new character, we know that that's part of, that was the previous character that was removed. Because we're going to find that character in the round where the only characters are the characters that we already know the order of, and whatever was removed in this round. So again, the strategy is go backwards whenever we find a new character that was like the previous character in the round. So for example, in this list, we would generate, first we found C, then we found C, then we find A. I'm not going to draw the arrows. Then we find A, and then eventually, after going through, we find B. And that gives us the reverse order. We know C was removed last, we know A was removed next last, and we know B was removed first. So reversing this, we get BAC, which gives us the order. Verifying this with the sample, it is correct. So the algorithm turns out to be simple for finding the order. Go backwards through the string every time we get a new character, append that to the end of the reverse order, then reverse it at the end. So how do we so why am I talking about frequencies also? Well, one way to find out the initial string S is, we know S is going to be at the beginning of T. We just don't know how many characters it takes. But if we can find out the frequency, if we can find out this for every character, then we just sum the frequencies up, and then that gives us the total length of S. And then from the total length of S, we just take that many characters off of T, and then that gives us S itself. Yeah, so how do we find the next frequency? So we know the frequency of C is the number of C and T divided by 3. And what about A? Well, we know that A is alive for 2 rounds because it was removed in the second round, which means it's alive for 2 rounds. So this X value for C will be 3. For A, it will be 2, and for B, it will be 1. Because A is alive 2 rounds, B is alive 1 round. So using this, we can also deduce, if we index these with 1, 2, and 3, then this just gives us the numbers we need to divide by. So it's number of C and T divided by 3. This is number of A and T divided by 2. And this is number of B and T divided by 1. And that gives us the frequencies in S, because we know the number of rounds they were alive for, and yeah. So if this is ever not divisible, then automatically it's not possible, because it just isn't. Because if it's not divisible, then how did that even happen? There's no way it can be alive for that many rounds, and it can't be divisible by that. It's very confusing. It is the letter S. Not a less than or equal sign. Yeah. Yeah. So now we know S. And then this is the easy part, I guess. We just need to check if it's possible now. So basically we just simulate the process. We do this. We start off with S. We know the order, so we remove all of the first character from S. Then we append the new string on, we remove all of that character, we append it on, and at the end we can check if it's equal to T. My code actually doesn't do it so simply, but you can actually, first I'll just go over the rest of the code. So first, find frequencies in T. This is F of some letter is a frequency in T, not in S. So I'm going backwards. If this is a new character, using a set isn't necessarily efficient, but it doesn't matter. If it's a new character, it's at the new front of the order, or it's at the back of the reverse order. Then now, I'm using these formulas to find out the frequencies of the characters in S. This count is just the length of S. And if it's ever not divisible, we say it's not possible. So it's not possible for a -1. Otherwise, now reverse the order for it to be normal. This V is going to be equal to S, but because I have a set called S, I just called this some other letter. And then this is the position in T. So basically, instead of explicitly generating the string that S would become, I'm just... What am I doing? What am I doing? What am I doing with my life? Deep questions. It's just I sort of lost track of what I was saying. Yeah, to find out if the string generated by S is exactly equal to T, I'm just like comparing S to the positions that it matches with in T. And then the new character should match with these few positions, or the new strings to match with these few positions. So I check if that string matches these positions. And then now the new string should match these positions, and so on and so on. So I'm maintaining a pointer to like the beginning of the positions that should match, and then I add the length of S every time, so it like jumps forward that far. And if it's ever not possible, like if we go past T or it doesn't match, then it's not possible. You can combine these if statements, I don't care. Then I'm generating the new string every time. This is O of n times 26, which is fine. And then I'm also decreasing the length of S by the number of characters we remove, just because like the length has to be updated. But in fact, like you can just set this to the length of cur, or the current string, it doesn't matter. It is not possible for -1, otherwise print the two things we need. The string itself, the string S, and the order. Yeah. So that's a thing. And now F. Okay. F1 is, or my solution to it was simple, although my solution to F2 is not. For F1, all I did was, you can notice that there, for k being less than or equal to 2, there aren't that many beautiful numbers. In particular, like for k equals, zoom out. For k equals 1, the only numbers are like 1, 1, 1, 1, 1, 1, etc. up until you have 10 ones. Because by that point, like you're going past 10 to the 9th. So this is only 10 numbers. You have 9 valid digits. So there are only 90 numbers with k equals 1. I think somehow I had more, because I generated a bit past this, but it doesn't matter. Then for k equals 2, well, what happens? Essentially, you have 10 choose 2 possible digits that can be used, which is 55. And then each set of digits like each set of digits will well, what will it do? And like, sorry, each pair of digits can, like, essentially the numbers that are possible. Say you have 11, or say you have 10 spots. Maybe 11? No, only 10. It doesn't, yeah. Then like, suppose you have like 3 and like 7. Then each digit can either be a 3 or a 7. There are 2 possibilities for each. So you have 2 times 2 times 2 dot 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 equal to 2 to the 10th. So the number of possible numbers at most is 55 times 2 to the 10th. Maybe it's like, it might be a bit off, but it's around that. And this is not that bad of a number. So you can generate them explicitly, and then that just gives you like, that gives you everything. From there you can just use like a set, and then you can like use lower bound or something. You can binary search to find the largest number, or the smallest larger number. The smallest number that's not less. So doing this, I just generate it explicitly. I iterate over the pair of digits, then the length. Oh yeah, the length also matters. So there are a few more than this, I guess, because maybe you have like a 5-digit number instead, or something like that. But it's not that big a deal. And this is actually 2 to the 10th plus 2 to the 9th plus 2 to the 8th. So it's somewhere around that, like 100,000. It's not that much. And then, yeah, and then like basically it's a bit mask where 0 represents taking the first digit and 1 represents taking the other one. And then you just add on that digit. This is like standard bit mask stuff. Finding the jth bit in I. Put that in, use sets, lower bound, everything's good. Everything is not good in F2. Probably gonna make this the thumbnail. Yeah, so this is what happens when you know you're hackable and you like panic or something. I didn't do F2. So F2, there is some way to explain this that is nice, I'm sure, because a lot of people solved it like fairly quickly, or a decent amount of people, that that my solution is just way off and there's a much simpler way to do it. But basically what I did was, it was sort of greedying. Basically, like, consider the number like, I don't know, some number. Like 3, 7, 8, 6, 5, 9, 2, 1, I don't know, something. The digits don't have to be distinct, of course, but it's basically like, say k equals 4. What we want to do is we want to maximize the length of the prefix that works. Because if we can do that, or the length of the prefix that's the same, because we want to minimize the number, so we want as many of the digits to be the same as possible, and then maybe this is like larger, or maybe it's also the same. But suppose like k equals 4. So first we try just making the first digit the same. Then this can be like, I guess, anything. And it kind of depends on what we do, but in this case, for example, we can take like, we can try 7 or we can try 8. I guess it doesn't really matter. Actually, there are really only 2 things we need to check, I guess. Like, no, okay, hang on. I need to find some way to explain what I'm doing, because what I'm doing is a total mess. Basically, suppose we decided what digits we're using. So maybe we're using 3. Then what do we do here? Maybe we use 7. Then what do we do here? Maybe we use 8. Then maybe we use 6. But the problem is now, we can't use 5. And the best digit we have is like another 6. And actually this turns out to be fine. Yeah, and then we can use like the minimum digit we have for the other ones. Okay, seriously, I need to just sit down and think about how to explain this. Also, I'm going to hack myself. I can do this, right? How do I hack? Oh, it's still system testing. Okay, 1 second. I'm gonna hack my old solution and then hack it before anyone else does. What is system testing right now? It's just running some submission. Very confused. Okay, I do need to think about this some more. Genuinely just need to sit down and think about what I'm doing. It is not a good solution by any means. Okay, I guess here's the idea. We choose some match. Then maybe the characters we have like aren't enough. Like for example, suppose we only have 3s. Then this isn't big enough to work. Are you serious? I hate this bug. Suppose like this isn't big enough to work, right? 3, 3, 3, 3, 3, 3, 3. I don't know if that was 8, but if we have 8 3s, it's not going to work. So what we consider doing is we raise this number by 1. And we give up on matching this character, but then like we guarantee that it's going to be greater now, and then we fill it in with 4s. So considering only the 3 isn't really worth it. So maybe we consider the first 2 characters. But actually suppose we do consider only the 3. Then we consider the 3 and then we raise it up to 4 because we have to. And now because we have a spare character, we want to make these as small as possible. So we can also use like 0. So we're iterating over like the prefix that we match with, or like the set of characters that we're initially considering. So now we have 3. So now we tried using only 3, it's not really that good. Maybe we also try 7. So once again, 7 isn't enough because we have this 8 here. So what we need to do is we need to raise this one up. Or actually, what I'm doing in the code is just iterating over the one I raise up. So maybe I do raise this to a 4, and then we try that, and then we get like something like this. Or maybe I raise this to an 8, which is better, and then this becomes an 8, and then we also add on 0 because we have an extra character, and then we do that. Now we consider the next one. Maybe we add on 8. So now what do we do here? Well, we're essentially just trying to put on the largest character we can, so the best we can do is have something like 7. And then because we have an extra character, we can use 0, so we can stick that on there. In this case, we don't have to raise anything, but still in the code, I'm trying also the possibility of raising just in case. And then maybe we have a 6 here. And now we can't stick on a 0 because that would be too many. But when we try doing this, for example, now we have this, so it works, and then we can stick on like the remaining minimum character. So the way I'm handling like the rest of it is actually like very dumb. Hang on. Let me just get this out of the way. Rip 7th. Because right now, it's over. I think. Yeah. Sent me a notification about my own hack. So that should bring me down to like, my other solution should save me, but I have this awful penalty now. So that, yeah, 223 as I predicted. Okay. Anyway, that had to be done, because if not, like I literally recorded myself generating a hack test, so someone else would figure it out. Or someone would just try it, because you usually try to hack like the top 10. Or top X or something. Anyway, so the way to like fill in the numbers once we know the digit we're using is kind of annoying. So what I just did was like I just made a digit DP. We're essentially like given a certain set of digits, what's the best number that we can use? That's what the digit DP will compute. And well, like it works basically. For a specific set of numbers, it will find the optimal answer. And so that handles most of the casework. So the only hard part is finding like the set of numbers to try. And if we try all sets of numbers, as I found out before, that will TLE. Probably should have benchmarked that, but at that point I was just frustrated. So I could have saved myself this penalty. Like I could have saved it by benchmarking it. So maybe it would be higher. And I probably could have saved this. Could have saved this too by benchmarking. And probably not have wasted so much time on it. So yeah, that would save 3 penalties. But whatever. Yeah, so it's kind of cool. When you move the cursor, it sort of like trails back color using. Anyway. So the casework is like trying the different sets of things. So essentially, iterate over the prefix of like the characters that we want to match. And then consider, if necessary, we add 1 to each of them. We consider like picking 1 and then adding 1 to it. And then we try that set as well. And then also, if we have an extra character to spare, we also try adding 0 on, because it doesn't hurt to do that. Like, we might as well add 0. Actually, you can also try like adding on every character if you want. You can brute force the character you add on. That doesn't hurt either. The point is, it doesn't hurt to try more and more sets, but we're narrowing down the number of sets that we try. And in general, the number of sets is like the length of the prefix that we try, or the number of prefixes, which is at most like 10. 10 times the number of things that we do, which is we can add 1 to each of them. So maybe 10. Another 10, or like smaller than that. And then it's that times the complexity of digit DP, which from my implementation was around 10 squared. So in total, it's around 10 to the 4th operations per test case, which was not nice. And it took around 200 milliseconds, but it works. Yeah, I don't know. I don't know what this problem was. Kind of want to just look at some other solution and see. Anyway, yeah. So this is find the digits, iterate over the prefix. If we get a new character, then put it into like the set of consider characters. Then if we have an extra space, put in 0 and then remove it at the end. Then for each character, we consider adding 1 to it, and then we try that too. So this basically just says run digit DP and see what we get from it. And then print the answer. If we ever have k characters, then there's no reason to continue, because we've already hit the limit we have. There's nothing new we would try. Yeah. So that's kind of a thing. So the reason this got hacked is because it did do basically brute force for k greater than or equal to 4, but the test didn't catch that at all. I kind of want to see, like, what did people do? Was it greedy, or was it like... It's kind of DP-like. I guess, yeah, okay. I'm thinking of it like, it's kind of also like a DFS, basically. Where you also consider the set of characters that you use, but like... It'll finish quickly, because again, the set of characters consists of only like, maybe you add 1 to one of them, but in most of the cases, it's only using the same characters as like the prefix of the string. What other people do? What? Does this fail? Wait. This doesn't feel like it works. Wait, what? want to see if other people are hackable too. Because the tests were really, 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 really bad on this, and this doesn't feel right. It feels like it could fail. Maybe it's like optimized? Oh, it's like this. Okay. Wait, what is it doing? It's removing one digit at a time. Is it? Okay, it's something smart. Yeah, I don't know. I guess it's right there. I'm gonna look at some other things and then... I mean, yeah, that was all the solutions. I don't really have more to say. That problem was a disaster. So yeah, I'll just see. Hopefully you got more out of this contest than I did. Maybe it wasn't pure suffering. So that would have been nice. But yeah, in any case, goodbye.